This is the self-assessment for lessons 2-1, 2-2, and 2-3. Review of the answers. Question 1. Evaluate f of 4 to the nearest tenth when fx equals 3.2x squared minus 9x plus 1. So what this means is we're going to take 4 and we're going to plug it in for x in two different places. And we can do that. I'll show you just using the calculator. You do 3 parentheses 4 squared minus 9 times 4 plus 1. Hit enter and we get our first answer, 13. So that was our first answer, 13. Our second question, question number 2, we're evaluating an expression. So that means that wherever we see an x, we're going to plug in 3t. So now this becomes g of 3t equals, and I think I almost want to say you almost don't even need to rewrite that, so I'm going to like ghost it out like that. G of 3t equals, because really the meat of the problem is taking this 3t here and plugging it in for x. 3.2 times 3t squared plus 5. So we just have to remember what we remember about when we square something. So this is really 3.2 multiplied by, we'll just do it step by step, 3t. When we square something, we multiply it by itself. 3t plus 5. So just using our rules of multiplication, 3.2 times 3 times 3. That's what goes together here. So 3.2 times 3 times 3. And that's going to give us 28.8. So we could say this equals 28.8. Then we have a t and another t being multiplied together. So that's going to give us t squared. So 28t squared plus 5. So this was your answers for questions 2, and then your answer for question 1 is 13. All right, moving on, we have what seems to be the domain and range of this function, and I gave you the equation, and I said use the Desmos calculator to graph the function. And we're going to be looking again at the graph for question number 4, because we're going to be looking at why is this a function as opposed to not a function, right? What makes it a function? So let's go to our Desmos calculator, and I already have this up. And here it is. And I graphed it. Okay, if you have any questions about how to make this graph pop up or how to type that in, I mean, you just type it in like you see it. You can use the up arrow above the 6 to get the x up in the exponent, and then pop down -3. So that's our graph, and let's just kind of interpret it. We're going to look at the domain and range. So we can move this graph in and out to look at the domain and the range, kind of look at what the behavior is going on. And I'm actually going to take this, let's take a picture of it. Alright, so if we did that right, it should pop up right here. So let's take a look. So here we go. So our domain and range. So we get that the domain of this graph, we notice that when we learn this, we'll learn about how we have an arrow that's going this way, an arrow going that way. So the domain, we'll just use D, would be the left to the right. So it's pointing to the left. So since it's pointing to the left, it's going to negative infinity, and it's pointing, I guess it's going down, but it's also going right. It's kind of going on a diagonal. When you go diagonal, you go two directions, down and this diagonal is going down and to the right. So negative infinity less than x less than infinity, that's our domain. And then for our range, right, that's kind of the bottom to the top. So the lowest the graph goes, it's pointing down. So it's going down towards negative infinity, less than y. And then it seems to be stopping here at 3, right? -3. So we would say the upper bound is -3. And I would take on this kind of either one. I mean, the answer really is less than -3, but if you put less than or equal to, because it looks like it's equaling that, that's fine. We haven't really gone over exponential functions and how they have what's called an asymptote yet. So if you put just a less than, or if you put the less than or equal to, that's cool too. I probably would have given you the points on this. We haven't learned that yet. All right, next thing is talk about this, whether or not this is a function. It is a function because a function passes a vertical line test no matter where you draw a vertical line. Okay, you're only going to cross through this graph one time. Even like here, They're only crossing through one time because it's kind of moving to the right. So as it appears, what makes the graph a function? The graph passes the vertical line test. Right? That would be an appropriate answer. If you just said it passes the vertical line test, if you describe what the vertical line test does, that's cool too. Okay, but that's a good answer. All right. Our last set of questions, we use this table here. Use the table below that reports freshman fall enrollment in degree granting institutions. That means colleges. All right, so we have 2000, 2004. First question says, find a linear model, that means a y equals mx plus b equation, for x equals the number of years after 1999. Now this is the big important part. This makes it so your numbers are easier to look at. So this is where we use our stat key, okay, and we edit our list and we put our list in here. Now notice that 2000 is really 1 year after 1999. 2002 is really 2 years after 1999, and so on and so forth. So that's how I put this in the table. That's your first step. Once you have that done, okay, once you have that in your table, what you can do, and I'm going to copy this. Just put it in there. Okay. Once you have that in your table, it's really, really simple to get to where you need to go. You stat, go over to calc, you go to 4 for linear regression. This is something that my 9th graders do, right? And then this is your linear regression equation. So we get this, all right, and from that we can write our model. So we have two different parts. We have our M, right, our A, and then our B right there. So our equation might look like y equal to, let's just say 7624 x plus, and we're going to round both these up because they end in point at 297. So 296,701. Boom. That's our model. That would be our equation. All right. Part B says, same graph. Use your model from Part A to estimate the number of freshmen enrolling in 2007. Well, 2007, right, if you're going to keep going, right, which year? 2007, okay, is blank years after 1999. All right, what is that? So that is 8 years. So this is where we're going to take our 8 and we're going to plug it in for our x right here. So we go back to our calculator. We're going to hit second quit to get out of this. That's not what we want. Second quit. Second quit. Isn't this always the way love goes? Okay. Wow, for some reason that looks like that. Okay, so there we go. So we plug that in. So we have 7624, and then substitute 8 in for x plus 296,701. Enter. All right, so we could say the number of freshmen. Okay, the number of freshmen enrolling is 357,693. That's an appropriate answer. Okay, so that's that question. All right, question 7, same table. Again, is this an example of interpolation or extrapolation? The answer here is extrapolation. Okay, 2007 is outside the data range. So this is the answer right here would be extrapolation because it's outside the data range that's provided. It's not between 2000 and 2004. Question 8, let's see, calculate the residual. So we learned about how to find the residual, or we will learn, is equal to the observed value minus the predicted value. Okay, so let's figure this out. So we got to figure out, well, what's our observed value? Okay, observed value, and that would be right here in the table. We have 2002. That's going to be right here, 318,982. So 318,982. Okay, and then our predicted value, this is where we go back and we use our equation. So we use the model that we found, all right? So we're going to use the same model we have up here. The only difference is 2002 is which year? It's how many years after 1999. So 1, 2, 3 years after 1999. So when we go to our table, we're going to use the 3. So 3 years after 99 plus 2, 9, 6, 7, 0, 1. Boom. That's our, and this is going to be our predicted value. So our predicted value is 319,573. And we would just subtract those. We would do 1, subtract the other, observed, minus the predicted, So here we have 318,982, subtract 319,573. Boom, we get our residual, negative 591. And we'll talk about residuals, meaning like the difference between what you think you're going to spend and what you actually spend. Like when you go to the restaurant, you might say, oh, I'm going to go to the restaurant, I'm going to spend $30 on dinner, right? And then really you get there and you spend $25. That's you're doing residuals all the time. You might say, oh, I'm going to go to the mall and I want to buy my best friend like a new sweater, right? And you get there and you're like, I'm going to spend $45 on the sweater, and then the sweater ends up costing $50. You spend $5 more than you think you would have. That's what a residual is. All right, last one, find the correlation coefficient. This tells us how good of a match the line is. So what you have to do here is we're going to follow the same steps we did all the way up at the top where we found this. Okay, the only difference is we have to turn the diagnostic on because the calculator can do this for us. So we go to second and then catalog, and then we're going to go down to diagnostic, right? And this is so much easier on the calculator that's not on running through my personal computer here. But we'll get there. So we go down to the diagnostic. I'm going to turn the diagnostic on because that's going to tell us a whole bunch of more information that we need. So diagnostic on, and then hit enter. And then when we go to stat, calc, and do our linear regression, our R value shows up, right? So our R, we get that our correlation coefficient is 0.983. You say 1 if you wanted. And that's going to tell us that the correlation coefficient, we were going to draw this, right? And we have our line, it's going to be a positive correlation, right? And the dots on the line are, for the most part, pretty close to that line because it's 0.983. If we were going to plot the points, it would be almost all in a line. That's what that tells us. All right, that's the end of the video.